Okay, so here in chapter 6, we're talking about anti-differentiation again. So again, integrals, but by substitution. So remember in the last chapter, we kept saying, okay, you can integrate, sine of x. But then remember I kept saying, like people kept asking me, well, what if you have sine of 3x? And I said, yes, you could do that, but you sort of apply something like the chain rule. Well, that's what we're going to do here. We don't call it chain rule. It's called substitution. Okay? So it's basically for all of those functions which have, which are composite functions. All right? You remember, okay, so this is the list of formulas, integration formulas, antiderivatives. This should look very familiar to you because there was a sheet, there was a page in your last chapter notes where I said formulas from 6.2, and this is it, formulas from 6.2. So your book gives you this in chapter 6, but you realize it's not possible to do chapter 5 without them. That's why we switch things around a little bit. Okay. Now, so these are so these are all of the formulas. Now you will understand why the u's are here, all right? Because it's not always just x to the n. It's, sine squared x and so on, right? So here, we write integral of cosine of u, not just x, because you could have the function look like this, cosine of x dx. But how often does that happen? Most of the time, there's a nested function in there, like cosine of x squared plus 1 dx and so on, right? So for these cases, whereas for derivatives, you would look at something like this, cosine of x squared plus 1, and you're like, chain rule. Here, we're doing substitution. All right. Okay. So, all right. So let's take an example here. All right. So the substitution method, and like I said, it's like chain rule in reverse. All right. Is this: if f of x is the derivative of this, right? So if capital F is the integral, then f of u of x, so this is like this, sorry. F of u of x times u prime of x is f of u of x plus c, okay? All right, so what we're going to be doing here is we use the term u substitution, okay? All right, so let's come up with some cases where we use u substitution and where we don't need it. So suppose I have something like this, x cubed dx, okay? We can do this. We know how to do this, right? So this will be x to the 4 over 4 plus c. That's it, plain and simple. But now suppose you have something like this, the integral of 3x minus 1 cubed dx, okay? So suppose you're like, oh yeah, I know, anything with an exponent, you add 1 to the exponent, and then you divide by the new exponent, right? Well now, if I were to take a derivative of that, do I get this back? No, what do I get? If I take a derivative, the 4 comes down, so I have 3x minus 1 cubed times what? 4. Times 3, right? So let's take a derivative of that. Minus 1 to the power of 4 over 4. Let's take a derivative. The 4 will come down, so I have 4 over 4, 3x minus 1 cubed times the derivative of the inside, 3. So I get 3x minus 1 times cubed. So the way I have this now, when I take a derivative, I don't get the same thing back. I get times 3, right? That means here I need to modify and do something else. All right? So what do I need to do here? In order for me to get that back, I have an additional 3, so I need to divide by something in order to cancel things out. Okay? So this is why, and then there's a plus c. So this is why we need u substitution. So here, no substitution. Here, you need substitution. All right? So we've ascertained the need. In what situations, what type of situations is this needed? Now let's talk about how we actually do this. All right. Well, I just said you have to introduce a 3 from the outside in order to balance this 3 here. Right now I kind of worked backwards and I'm like, God, I need to figure out a mechanism to put that 3 there on its own. Well, this u substitution is the mechanism. Okay? All right. So the way u substitution works is this. Remember, for all functions, even before, we had an inside function and an outside function. Like in here, what's the inside function? 3x minus 1. And what's the outside function? Something cubed. All right. So for u substitution, we say u is going to equal the inside function. So look at this function here, 2 sine 2x. This is what's inside the sine, so u is equal to 2x. So your first step is determine the u. This, for most of us, is the more challenging step. Okay? This is the one that you have to get right, and then it all falls into place sort of later. Now, once you determine what u equals, then you have to find du. So here we said, okay, u is 2x. Okay? This is what we're integrating. So if u is 2x, then d dx, so du dx, right, is equal to how much? 2. But now, I need to take this and I need to solve it for du. So what's du? 2dx. Okay? Everybody know how I did that? I multiplied both sides by dx, so I put the dx over here. Now, remember, this is still my original function. Now I need to rearrange this so that the inside function goes away. Okay, so here's what I'm going to do. I have a 2. I have a sine 2x. Remember the 2x I said is my u, right? And then how much is dx? Okay, so 2dx is du, right? So how much is dx? It's du over 2. Right. It's du over 2. So another way I could do it is this 2 and this dx together are what? The 2 dx's together are du. So now look at what I did. This is u and this is du. So I can rewrite this as sine of u du. Okay? Now that you don't have an inside function anymore, you integrate. That's negative cosine of u plus c. And then you have to substitute back in. So if this is negative cosine of u plus c, then this is equal to negative cosine of 2x plus c. Okay? All right, so let's do one here, and then you'll see. So it's basically like pieces of a puzzle that we put together. All right, so let's do this one. This one is x minus 7 to the power of 3. And we have to figure out what the inside function is. It's x minus 7, and I've actually given you what u is. All right, I'm not going to do that all the time. So u is this. And we say du is equal to dx. So now look at what happens. When you go here, this x minus 7 is u cubed. Okay? So I just substituted that. Now what's left over in the top? Dx. What you have to do is you have to use this in order to substitute for everything that's left over. Now dx equals du, so that's what we have. Okay. Now that it's just u, now that it's just in terms of u, I can integrate like I did in chapter 5. So that's going to be u to the 4 over 4 plus c, and that's equal to x minus 7 to the 4 over 4 plus c. Okay? Innocent enough. Right, remember when you integrate, the dx's and the u's go away.
I thought it's like, oh.
Yeah. Because what's u? U is x minus 7. Here I have x minus 7 cubed. So x minus 7 is u cubed. You just substitute. Okay, let's do one more. I have 2e to the 2x. All right? The inside function has to be the u. Well, now I have e to the 2x. That 2x is u. So let's see what du is. Du is equal to 2 dx. Okay, let's go here. E to the 2x is going to be what? E to the u. Now, what do I have left over? I have a 2 and a dx, right? What's 2 and dx together? That's just du, right? So I make that du. Because look at what I did here. When u was 2x, what's du? 2 dx. You see that? So now you have to find a way to massage that into this. Okay? You literally, it's like a puzzle. You have to like conform things to fit the way you want them to fit. So now that's just e to the u plus c, which is what? E to the 2x plus c. Is that okay so far? Okay. Let's do one more. Okay, so look at how complicated this one is. You always want to go into the inside function. So the u is going to be the inside of the root, x squared plus 1. So go to the more complex function and take the stuff inside. So u is x squared plus 1. That means du is what? 2x dx. Okay, so here, this is going to be the u. All right? What do I have left outside? 2x dx. Right? Huh? Yeah, I have the square root right. So, oh my God, okay. So I have the square root right. So it's root u. I got that one. But then what else do I have left? 2x dx. And what's 2x dx? Magically, that's du. Okay? So some people write it this way. So some people say, all right, I'm going to rearrange this. Okay. Some people do this. Some people say, let me rearrange it. All right, this one without substituting anything. X squared plus 1, I'm going to write it on the left side, and then I'm going to bring 2x here and just put them together because it's easier for them to see that now this is just du. So it's up to you. You want to rearrange. You can just see it when they're broken up. That's up to you. Point being, this is the square root. This is the integral of the square root of u du. Okay? Now, that transforms to a chapter 5 problem. All right? So this is u to the half, the integral of u to the half du. So now we integrate. So this is u to the 3 over 2 times what? Times 2/3 plus c. So that is 2/3 x squared plus 1 to the 3/2 plus c. Okay?
How do you get 2/3? We shouldn't have this.
Okay, because if you have u to the 3/2, right? So what happens? You add 1 to the exponent, you get 3/2. Then you have to divide by the new exponent. And dividing by 3/2 is the same as multiplying by the reciprocal. Okay. All right. Let's do one more. Oh, look at this one. So I've given you what u will be in this case. But let's see what the reasoning is behind it. I have a sine of x, and then I have e to the cosine of x. Look at the more complex function. Sine of x is simpler. E to the cosine x is more complex. So if this is my complex one, then I take the function inside, and that's cosine of x. Okay? Again, figuring out what you will take as the u is the most challenging thing that you will do. Okay, so we have, what do we have here? We have a sine, and we have an e to the cosine. So between the sine x and the e to the cosine x, the e is the more complex. So you focus on the complex one, but then you want to take the inside function. Whereas by default, it used to be e to the x. Now we've inserted a cosine in there.
It's the same thing before.
Correct, with the chain, yeah. Yeah. So that's why u is the cosine, right. So now du is sine x dx. So you see how they're built? When you take du, that automatically gives you the stuff outside. So look, sine x dx, that's du. You see that? So look at what happens now. I have e to the u, and then sine x dx is du. Because what's the derivative of sine?
It's like the going
Yeah.
backward. Oh, okay.
Yeah.
I was thinking like the
Yeah.
original. Okay.
This is the integral. So then this is going to be e to the u plus c, e to the cosine x plus c. Okay, let's check. Let's pause for a minute and check. What's the derivative of e to the cosine x? E to the cosine x times what? Times what? Times now we need the derivative. Oh, wait, you were right. There is a negative. I'm sorry. There is a negative. I'm sorry. Okay, let's go backwards then. Yeah. Huh? Yeah, I'm sorry.
Oh yeah, because that's the.
Yeah.
Right. Sorry. Du is negative sine of x. Okay, I'm sorry. I forgot we were taking the derivative. So the derivative of cosine is negative sine of x. Okay, so now where does that leave us? I'm going to erase this for a minute. Well, it's not that wrong. Don't erase it, but I'm just going to start over. So now sine of x dx is what? Sine of x dx is negative du. So, no. Negative du is sine of x dx. Okay? So now what happens here? Sine of x dx is negative du. And then I still have e to the u. So it's the same, just with a negative out front. So then this is going to be negative e to the u plus c, negative e to the cosine x plus c. Okay? All right. So let's do this one. This one's similar to what we just did. Okay. Again, I have something to the power of 4. The inside function is 3x plus 1. So that's u. That means du is 3 dx. Okay? So, if this is u, and I have u to the 4, I need 3 dx for it to be du. But look at this. I don't have a 3 here. There is no 3 in there. Right? Right. So then I need to conform that to look like this. So here's what I do. When I substitute this as u to the 4, okay, what do I have left over up here? Just dx. And how much is dx over there? Du over 3. Yeah, 1 over 3 du is equal to dx. So then, here it's going to be u to the 4 times 1 over 3 du.
Why is it like that again?
I like this better because then we can take this out. Okay, so we said that this is u and I have u to the 4. So now this is taken care of. What do I have left over? Dx. So now I need to substitute for dx. So I go back here. How much is dx? It's 1 over 3 du. Right? So I need to solve this.
Because you took the derivative of 3x plus 1.
Right.
Which is 3.
Which is 3 dx. But here I only have dx to substitute, not 3 dx. So I need to get this alone. Okay? All right. So now, this is 1 over 3 u to the 4 du. So that's 1 over 3 u to the 5 over 5 plus c. So, in the denominator, now that gives me 15. So I have 3x plus 1 to the 5 plus c. There is no times 3 anymore. The 3 went away. But in the bottom, I made 15. I made that 15. Okay. All right, let's do one more, and I think it'll start sort of sinking in. Okay, take a look at this one. I have an x squared. Then I have a square root with some stuff inside. What's the more complicated function, the x squared or the square root? The square root. So I focus on that, and I go to the inside, right? And inside is 5 plus 2x cubed. So that is what u will equal. Okay? Everybody okay with that? Okay, once you figure out that that's the u, let's take a derivative of it.
But doesn't it just tell us it?
Well, now I tell you. It doesn't tell you. I've told you. But neither I nor it will tell you all the time. Yeah. So, okay, so du is what? 6x squared. Right. Yeah, there you go.
Is it 1/6 x? Is it like 1/6 x squared?
Yeah, okay, so a lot of you guys have already jumped ahead here. So what's going to happen here is this is going to be u, right? So I have the square root of u. Now, what do I have left over? X squared dx. So there is a dx here. All right, so I have x squared dx. So this has to equal whatever the blue parts are, x squared dx. All right, so how do I rearrange this so that one side is only x squared dx? Divide by 6. So 1/6 du is x squared dx.
Where does the 6 come from?
Because of this derivative. I took a derivative of this, so 3 times 2 is 6x squared. So 1/6 du is going to go here. Now it's up to you. You can do 1/6 du, or you can do 1/6 du. It's all the same. Okay? So that's 1/6 du. Which x squared?
Oh, no, no.
X squared dx together was 1/6 du. So now this is 1/6 integral of u to the half du. So this is 1/6 u to the what? 3/2 times what? 2/3 plus c. So that's 1/9 times what? 5 plus 2x cubed, 3/2 plus c. As I said in the beginning of the period, it builds on what we did last year. I mean, what we did last chapter, right? So it's the same thing, but building on. Okay? This is like 95% of the time, these are the functions that you're integrating, because it's never just e to the x. It's always e to the 5x. It's never just the square root of x. It's the square root of sine x. Okay? All right. There is even another way. Like there are situations where even this doesn't work. So then we have to do other things. We have to do integration by parts. A lot of times to do integration by parts, you need partial fraction decomposition. Do you guys remember that from pre-calculus?
No.
Some of you guys should. Partial fraction decomposition. So that's why we learn all that stuff, is so we can do it here.
I don't think I remember the names of what they are, but I saw it.
It was 6.4.
Oh.
Okay. Here we go. Now, as promised, you're not given a u. Okay. So, let's think. What will u equal here? 2x minus 3. So du is 2dx. Okay. So here I have u to the 4, and then remaining, all I have is dx. So I need to make this look like dx equals something else, right? So that's going to be half du equals dx. Oh, okay. Okay. Are we okay with why we did that? No. Okay. Let's see. Here's why I did it. Here's my integral. This is u. So I have u to the 4, right? So now that's done. I've substituted for that. What have I got left over? Dx. Okay, so this is what I had before. What is dx? Half du. And I write it as half du. I like to split it up because it doesn't bother me. So then half u to the 5/5 plus c. So 2x minus 3 to the 5. Yeah. I know. Eventually you get the hang of it. You just have to do a lot to get the hang of it. Okay? So I always say this, like if you students are always like, well, when you do it, it looks so easy. Well, because before I came to this room, okay, like by the time I got here, I've done thousands and millions of them, right? I mean, so now it looks easy. When I was sitting there and it was my first time doing it, it wasn't as seamless, okay? All right. Yeah. Okay, so ln cubed x always throws people off until we realize, yeah, that we can write it as ln of x cubed.
Over x.
Right. So it's ln of x cubed over x. So now I have ln of x cubed and I have x. What's the more complex one? Right. So what's u going to be? ln of x. Okay? So u equals ln of x. So that means what's du? 1 over x dx. Okay, so here's what happens here. I have ln of x cubed over x. Can I write that as ln of x cubed times 1 over x dx? So if I have that over x, can I just say it's that times 1 over x? Yeah, I could do that. Okay? So now, look at what happens here. This is u cubed, right? So that's u cubed. And then what do I have left? 1 over x dx, which is exactly what du was. Like, oh my God, seriously, how awesome is that? Oh, you get it? Oh. Okay. So now this is u to the 4 over 4 plus c. And then it's, okay, so here you can write ln of x parentheses to the 4 over 4 plus c or not, or you could do ln to the 4 of x plus c. It's the same. Okay? Okay. Having said that, you know what? I think I need to take a minute and clarify that. Okay. So ln of x to the 4 is the same as ln 4 to the x. Ln of x to the 4, like this, is not the same as ln of x to the 4, right? Why is that different? Because here it's the x that's being raised to the power of 4, so it's ln of x to the 4. So be careful. If you don't want to put parentheses, you have to write it that way. If you write it this way, it's wrong. I can't give you all the points for it. It's wrong. I mean, and it's sad to have done all that and then lose points for that. Okay, one thing, when you're doing this, so again, now we're going to get to what I was talking about earlier. When we do it here, because I'm guiding you, you know, it's so cute, it's so nice and so awesome that everything just sort of fits, okay? When you do this, and there is no way for you to substitute so that everything goes away, if, when you put it in terms of u, you still have x's in there that you were not able to make go away, right? Then you've done something wrong, okay? Because you cannot integrate something that has a u and an x, okay? All right. Okay, one more. Ooh. Okay, so what do you guys think the u will be? Okay, good. All right, so tell me, you guys lead me through this now. Uh-huh. How much x dx? 2x dx?
And then it becomes 1/2 du x.
Oh my, look at you guys. Okay, so now let's integrate. Okay, so x dx is what? 1/2 du. Okay, now what happens in the middle here? It's 1 over u, right? Because if the x dx goes away, then I have a 1 here. It's 1 over u to the half. Sorry. 1 over u to the half. Okay? Awesome, guys. So this is 1/2. I'm just so proud of you. U to the negative 1/2 du. And now it's just chapter 5. So 1/2 u to the what? Half times what? Times 2 plus c. So, yep, it cancels. So that's just the square root of x squared plus 3 plus c. And then the next question will be, do you have to write it in the root, or can you just leave it as x squared plus 3 to the half? And what would the answer be?
Doesn't matter.
Doesn't matter. Awesome. Good. Okay. Oh, look at this one. Missing some parentheses. Okay. Would the u be x cubed plus x? Yes. Awesome. Fabulous. And then for this one, you're just like, oh my God, there is no way things are going to go away here. But then you take du, and it's 3x squared plus 1 dx. Like, oh my god. Like, seriously? Oh my gosh. How awesome is that? So, it's just u squared. And then all these together are du. Right? So it's u cubed over 3 plus c. 3x squared plus 1 cubed over 3 plus c. Oh. Thank you. I know. We're just looking at the wrong place. Oh my god, it's 11:30. How did that happen? Okay, we're going to pick up from here tomorrow. However,